Hi, I'm Ashley, an AI and autonomous vehicles enthusiast. Imagine that it's a hot summer day. The sun is scorching on your skin, sweat beating down your face, and inefficient fans aren't keeping the hot air out. This is the everyday reality for many people living in India. In fact, in 2016, a town in India, Pelodi, reached a record high of 51 degrees, and the max temperature humans can survive at is 42 degrees. What's even crazier is that about 90% of these people don't even own an air conditioner because of its electricity and upfront costs. The number is only expected to grow in both developing and developed countries. The problem, however, with current air conditioners are that the refrigerants that are used, hydrofluorocarbons, have a global warming potential of 1,000 to 3,000x more than CO2. 30 to 40% of electricity demand in buildings, which contributes to a total of 117 million metric tons of carbon dioxide, which puts the world in a vicious cycle. The same thing that is responsible for cooling us is warming up our planet. This is why the amount of AC usage is expected to triple by 2050. Electricity usage from 2,000 terawatts to 6,000, which means that every second there will be 10 more greenhouse emitting ACs installed. So, how do our buildings actually get heat up in the first place? Most of the sunlight falls on the roof, and every ray has a certain amount of energy that dissipates and heats up the building. That's why we want to introduce Coolity, a sustainable way to cool the world using programmable materials. We believe we can reduce the temperature within the house by 10 degrees Celsius, cost for developed and developing countries, and provide a no energy usage method of cooling. So, a simple analogy for this is how plants actually cool themselves. The process is very simple. Every sun ray carries a certain amount of energy, and these leaves have a water coating on it. So most of the energy from the sunlight goes for evaporation of this water. So the heat doesn't actually reach the space inside the leaf. We're implementing a similar concept with an artificial skin coating that will prevent the heat from ever reaching the inside of the building. So we're using something called hydrogels, which are these programmable materials, the same thing found in your contact lenses, and are three-dimensional networks of hydrophilic polymers that can swell in water and hold large amounts of water. We're using something called double network hydrogels, which are just two networks combined together, one with for flexibility and another one for toughness. It's so tough, it's as tough as animal tissues, and it's able to trap water because it's 90% water. We're also using chitosan and PVA since it's cheap and possesses all the necessary properties of our hydrogel. Material is biodegradable, so it doesn't harm our environment. Essentially, we're placing a 5 millimeter coating of hydrogels on the roof so it can prevent the sun's energy from ever reaching the home in the first place. Since the hydrogels contain water, the energy forces the water to evaporate. And during the night, the hydrogels are able to collect water from the air using dehumidification methods for the cycle to begin again without any human intervention. Here's a prototype we made of our double network hydrogels, and it also has a sticky coating so it's able to stick on buildings easily. The crazy thing is, it costs only 12 cents per square foot, so it can be widely implemented in the future. And the impact of this, up to 20 degrees cooler on the roof after single hydration, 35% reduction in energy costs, and a total of 140 kilograms of carbon emissions per household reduced for every year. Experts around think the same as us. The CTO of Google X thinks that our solution has a lot of potential, and a research paper that we looked into also validated our solution, talking about how the hydrogels actually work. And here's our wonderful team that worked on it.